This video, we're going to graph some linear inequalities in two variables. We're going to use the same graphing techniques that we've used in the past to graph lines, only sometimes the boundary of the inequality will be a line. Other times it'll just be a broken boundary line. That'll have to do if this inequality here has the line underneath it, which means or equal to. If we see that solid line underneath the inequality symbol, we have a solid line for our inequality boundary. If we don't see that, we have a broken line for our inequalities boundary. So I'll show you that as we go along. We have a couple options that we've used so far. We can use our intercepts, or we can put this in slope-intercept form to graph it. Let's go ahead and use our intercepts this time. Let's let x equal to 0 and y is 5. Let's let y equal to 0 and x is 5. I did the x first, sorry. They're both 5. X is 5 and y is 5. I have a solid boundary line here. Trying to do my best to get my line to go through my entire graph. All right, now because I didn't set this into slope intercept form, I can't just look and say, do I shade above or below? That's my second method, which I'll do in another example or two once it's in slope intercept form. But I'm going to use a test point here. I'm going to use the test point of 0, 0 when I can, just because it's easy, because all the parts with x's and y's become 0. So is 0 greater than 5? It is not. So the side with 0, 0, which is over here, is false. I guess I can't undo. Got too close to the line I drew, sorry. And so I'm going to shade on the other side of the line. There we go. I'm going to use my intercept method again here. X is 2. Y is 1. Broken boundary line this time. Down 1, right 2, 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 up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, 1 left 2. I should have a broken boundary line here. There we go. And going to put 0, 0 in again. Is 0 greater than 2? It is not. So I'm going to shade on the other side of the line that does not contain 0, 0. Okay, this one's already in slope intercept form. My y-intercept is at 0, 0. My slope is 4. Up 4, right 1. 4, right 1. Down 4, left 1. Down 4, left 1. Solid boundary line here. And because this is already solved for y, when y is greater than the line, I'm going to be shading above the line, which is up here. You can imagine your shading going up from the line, as opposed to if I was shading below the line, I'd be over here because my shading would go down from the line. All right, this one's also in slope intercept form. My y-intercept is at 11. I'm going to go up 1, right 1, down 1, left 1. And I have a solid boundary line. like that. And I'm going to be shading above the line, which is up here. Now I have a horizontal line, y equals 2, and it's a broken boundary. I want to shade below that line, so that's down here. Now I have a vertical boundary line of x equals -3. X equals -3. It's solid, I'm sorry. There we go. And x greater than -3, values that are greater than in the x direction are to the right. So I'm going to shade to the right. Again, go ahead and test a test point if that's easier for you. I could have tested 0, 0. 0 is greater than -3, so I would have shaded on the true side. This one is not solved for y, so let's go ahead and solve it for y, because there's not enough information here for me to find multiple intercepts, since there's only one intercept that goes through 0, 0. So let's get the y on the left, like that, just keeping the -5y on the small side of the inequality. I'm going to divide both sides by -5. When I divide by a negative, I change the direction of my inequality sign. My y-intercept is at 0, 0. I'm going to go down 1 and right 5. 1, left 5, up 1, left 5. I have a broken boundary line here. And I'm going to be shading above this boundary. Just use my test point of 0, 1 to test that. 1 is greater than 0. Yep, that's on the true side. Go all the way back to my original to make sure I didn't make a mistake. X is 0, y is 1. 0 is greater than -5. Yes, that's true. Okay, this is going to be my last one here for section 10.7. And we're going to use the intercept method again here because of how it's set up. When x is 0, y is 1. When y is 0, x is -4. Our boundary line is broken. 4, 4. All right, and I am going to use the test point 0, 0. Is 0 greater than -4? It is. So I'm going to shade on the side here with 0, 0. Let's confirm that by solving for y. Oh, I plotted my graph wrong. I see that now that I wrote this in slope-intercept form. That's why I double check myself. So my y-intercept is a -1. I put it on the wrong side of 0, I'm sorry. Down 1, right 4, down 1, right 4, up 1, left 4, 1, left 4, broken boundary line. And 0, 0 makes this true, but 0, 0 is above the line. And we see that we should be shading above the line because y is greater than. And so it checks out both when we use our test point and when we use our alternate method that tells us whether to shade above or below the boundary line. Okay, that's it for this video. Come back next time and talk about something else. So see you for the next video.